Hello everybody. In this video, we're going to cover the surface area of a square-based pyramid. So again, if you're able to go through the lesson and understand most of the content, then you should be able to complete the success criteria given here. So do that at the end, please. Okay, so let's get started. So first, we're going to consider a pyramid here. That's given here, a square-based pyramid with a base length of 6 centimeters. And something called a slant height, S, of 5 centimeters. So it's called a slant height because this length goes from the tip of the pyramid, the top, to the base here. Okay? It's not the height of the pyramid or the altitude of the pyramid because the altitude should go from the tip of the pyramid to the bottom center, the center of that square at the bottom. Then that would be the altitude. So therefore, this red line is called the slant height. Okay, so here, the first question asks, how many different faces does the figure above have? So how many different faces are there? First, there's a square at the bottom, so that's 1. And then there's this triangle, 2, 3, 4, the triangle at the back, and then 5, triangle on the left side of this pyramid. So 5 faces. There's 5 faces, but there are only 2 different faces. 2 different faces. So there's the triangle, because all the triangles are the same. They have the same base, and they have the same slant height. Okay, so triangle, and then the second one is the square. So there's only 2 different faces, but 5 faces in total. Okay, why is the red line above referred to as a slant height? Well, again, it's called a slant height because it's first slanted, and it's not the actual height of the pyramid like I described before. The actual height should go from the tip of the pyramid to the center of the square. So slant height because it's not the actual height of the pyramid. But the slant height is very useful because it's the height of one of the triangles. And again, because all the triangles are the same, it's going to be the height of all the different triangles, all the same triangles, all the 4 of the same triangles. So let's complete this table below. So we're going to write the face and shape, the face shape and diagram for the square pyramid up there. So one of the face shapes would be a square, right, at the bottom, the base. And the diagram is this with a side length of 6 centimeters. And each of these are going to be the same because it's a square. The formula for the area for a square, area of a square, is going to be S squared, side times side. Okay, so that's 6 times 6, which is 36, right? So we're going to do that in the third column. So the area is equal to 6 squared, which is 36. And that's centimeters squared. Okay, and then the other face, shape, and diagram is the triangle. So we're going to draw the triangle here. Triangle. And we have some dimensions here. The height is going to be 5. And the base is going to be 6. Shown in the diagram right there. Okay. So the area for the triangle formula is half base times height. So that's half times 6 times 5. Oh, I should do that in the third column. So area of the triangle is going to be equal to half times base, which is 6 times 5, which is height, and that'll come out to 15 centimeters squared. So the total surface area, which they want here, is going to be 36, the surface area of the square, plus 4 times the surface area of the triangle, because there's 4 triangles. So altogether that is 60 plus 36, so that's 96 centimeters squared. Okay, so just to recap, for a square-based triangle with a given slant height, this red line here, the way you calculate the surface area is just find the area for each of the triangles and then find the area of the square. And for these type of questions, it's going to be easier because you're given the height of the triangle here. Without the height of the triangle, it becomes a little bit harder because you need the height of the triangle to find the area of the triangle given or shown. Okay, so that's what we did. We got the surface area of the square, we got the surface area of the triangle, we multiplied the surface area of the triangle by 4 because there's 4 of them, and then we added the surface area of the square to get the total surface area of the square-based pyramid with the slant height. Now in investigation 2, we're going to cover a square-based pyramid without the slant height given. And instead, we're given something called the height. Okay, this is the actual height of the pyramid because it goes from the top of the pyramid to the center of the square. Okay, so we consider this new pyramid, and then what is the difference in information given? Well, we are given the height h instead of s, the slant height, sorry. Okay, so as you can see, the height is always going to be shorter than the slant height, because the slant height, if you look at any right triangle or try to create any right triangle, this hypotenuse here, is always going to be longer than the other sides. Okay, so what is the length of the green line segment? The length of the green line segment shown above in the diagram here goes from the center of the square to the side of the square. So that means this should be half the side length of the square. So this should be 3 centimeters. Okay, so 6 divided by 2, which gives you 3 centimeters. So the next question, what does the yellow line represent? Again, this is just the height or the altitude of the pyramid. Okay, next it asks, what is the length of the slant height? Okay, so if you take a look at the pyramid again, if you just consider the yellow, red, and green line, you get a right triangle. Okay, here's H, S, and we have 3 because that's what we calculated before. Okay, and H is also given, which is 4. So we can calculate the slant height by using Pythagoras. So slant height squared is going to be 3 squared plus 4 squared, right? So slant height squared is 9 plus 16, which is 25. And then we square root 25 to get s, which is 5. Okay, so what is the length of the slant height? Slant height s is equal to 5. Okay, now we have all the same information that we had with the one with the slant height, with the question with the slant height like this. So now the question becomes, finding the surface area becomes the same. You just follow the same process as before. So the face shape, one of the face shapes is a square again. And then you're given that each of the side lengths are 5. Right? Or 6, sorry, 6. This one. Oh, I made a mistake here. Oh no, I didn't. Okay, 6. So each of the side lengths are 6. 1 sec, sorry. Yes. Each of the side lengths are 6. So then the formula for the area of a square is again side squared. Right, so the area is 6 times 6, which is 36 centimeters squared. And then the other shape is the triangle. Okay. Square, triangle. And then we have a height. And this height is not the height of the pyramid, but again, the slant height. Because the height of the pyramid is different from the slant height. See, the height of the pyramid goes from the top of the pyramid to the center of the square, which is not the height of the triangle. The triangle is slanted, so therefore you need this height, okay, or that length. And that length we calculated as 5 using Pythagoras. So here we have 5, and then the base here is going to be 6 centimeters. So remember the area of the triangle again is half base times height. And then we're going to calculate the actual area, which is half times base, which is 6 times height, which is 5, which is equal to 15 centimeters squared. So our total surface area is going to be 36. That's the surface area of the square plus 4 times the surface area of the triangle, because there's 4 of them. So altogether, 96 centimeters squared. And that's the answer. Okay, so just to recap again, in this question we were given only the height of the pyramid, okay, not the slant height. And the reason why we want the slant height, this S, this red line, is because in order to get the area of the triangle, you need the height of the triangle. And the height of the triangle is not going to be H, the yellow line, it's going to be S. So therefore we calculate S by redrawing this right triangle and using Pythagoras. So we redrew this right triangle right over here. And we calculated S by using the side length 4, which was given, and the side length 3, which is half of 6 here, because the green line goes from the center of the square to the edge of the square, so it has to be half the side length of the square. So it had to be 3. And then we calculated S, which turned out to be 5 centimeters. And then that gives us the slant height now. So slant height is 5. So since we now have the height of the triangle, we're able to find the area of each of the triangles. And then finding the area of the square is trivial because we have one of those side lengths, which is 6. Okay. And then we added that all together to get 96 centimeters squared. Okay, so that's all I wanted to cover for this lesson. So if you have any questions, please email me. So I hope you are able to find the surface area of a square-based pyramid as long as you have the slant height or just the height. Okay. Okay, I'll see you next time.